Hi, and welcome to lesson 303, where we will be talking about batch importing and batch exporting using the Excel and Leap together. So in this video, I will explain to you the importing and exporting data to and from Excel from Leap. I'll explain how to do that, why there are quite a lot of benefits in using batch exports and imports, and some of the pitfalls or where you can actually really accidentally make errors in Leap if you're not being very, very careful. So I will explain some of these pitfalls so you don't have to do them as I have. So let's do that. So first we'll find a way to do import export. So we can only do import and export in this method from the analysis side. So we do not import export results like this. There are other methods for that. We will come to that in a later video. But here we will import and export input or assumptions. We do that by going into the analysis tab. Then we can see up here, and in there we have import from Excel and export to Excel. I highly recommend that you never do import from Excel in this manner unless you are absolutely sure that your format is right, because that is what Leap care about. And how do you make sure the format is right? Well, first you export some data to Excel. That can be zeros, that can be anything that you then change in Excel, but then you are sure that your format is as it should be, and that is quite important, and we will look at that in this video. Have a closer look. That is where it is, of course. So here we will look at how we export the branches to Excel and some of the options we have for doing that. So here we can see that we can go and we can even choose a specific branch in Excel. We can even choose a specific variable. Here we have chosen activity level and a scenario, in this case biogas digestion. So when we go and then we say export to Excel, we can see suddenly we can use that specific branch, that specific scenario, and that specific variable, and then we can export that in different ways. But we can also do it for all, which is what we're doing here. So here we can say that we can transform as expression and values, and we will go closer to that. Then we will have a little pop-up window that an Excel will also open, not shown here, but it will wait for that to export all the data. That can take a bit depending on the size and what you choose in your export. So in this case, it takes about 20 seconds, I guess. And you can see now we have suddenly quite a lot of the data in a tabular form in Excel. So now let's take a look at how the export expressions look like in Excel. So you can see here we have different branch paths in Excel, the variables, the scenarios, regions if you have them, scale, units, and so on. If we move along, we can also see here in this case we have the expressions because that's what we exported. That's basically what we write in the formulas in Excel. So these are all the ones that we have here. And then it will show us the different levels that is similar to when you show results and we say, like, we click on our model and we say we want to show levels 1, 2, 3, 4, 5 down and so on. And that's what we can see here if we have enough. In this case, our maximum level is at level 7 with some effects that we added before. And that is how that's how it looks like in Excel with a few caveats that we will come to. So in the previous slide, we exported things as formulas or as expressions, which is quite useful. I mean, we'll get into that is very, very useful later, but we can also just export them as our raw years, and we can also import this as that. So what the big benefit of that is that we can look at exactly how our data is in the different years, and also that means that we can graph our assumptions in Excel very, very easily for reporting as well. So let's do that. So if we go out to where we want to come from again, in this case iron steel, we say export to Excel, and here we're choosing to the format to be values for all years. You can also have it for default years that are just a few years. And now again, we are exporting our data set, and it takes a little bit. I guess in this case about 10 seconds before we will get our Excel window up. That's a good time to take a bit of water or tea or something, but you know, good. And now we have the same thing again. You can see we have the path, variable, and so on stay the same, but instead of the expression column, we now have a column for each year, all the way from our base year to our last year. And then again, we have the levels as we had before. That also means we can see very easily in Excel if something has changed or how much it has changed, because we can just throw formulas on these numbers, which is quite useful. So let's just have a quick recap of what exports are good for. So if you want to do something that Leap is inherently not that good at, and there are a few things that Leap is not good at. So if you want to make a further analysis of your input data, then it is very easy to export them to Excel and work with the numbers there if you have the yearly numbers and so on. If you want to make charting of different way, if you want to have a comparison chart between two specific inputs, it might be a little bit difficult in Leap unless you do something specific, but it might just be easier just to export these in different ways to Excel and then do it from there if you're good at that. You can also use the batch export to do batch import, which basically is having things you have made in Excel or changed in Excel, and then have that to make changes in Leap, and that's what we're gonna look at in the next slides. That's meaning we can use it for in a workflow where we just are re-exporting. We make our branches, we make our units, scales, everything. Then we export that to Excel. Then we change that in Excel using Excel formulas or just our general Excel skills. Meaning we can change things on a big level, batch level. We can do quite a lot, and then we can import that back into Leap. And that means in places where we would sit and do manual labor kind of work for up to hours, we can do that in literal minutes now. And that is something that I have used quite a lot and has benefited me quite a lot, the ability to do that while it's in this course. So let's look at that. So there is a thing that's kind of hidden in the Leap export, and that's the absolute ID tags, and that we'll just look at now because they're coming to be quite important, and you have to know that they're there if you want to do batch importing. So it looks like in Excel, you can see actually our starting column is E, where normally it would be A. So you could wonder where is the others. So what you do is you highlight E and you move all the way left, and then you say unhide, and then A to D is suddenly then shown. And there you can say we have branch ID, variable ID, scenario ID, and region ID before we have the data we already looked at. These are the absolute values that tells Excel where things belong, which branch, which variable, which scenario, and which region. So in this case, standard-wise, the scenario ID of 1, that's always the current accounts. That's a kind of standard thing. 2 is our first scenario, that it's numbered in the order that we make them. So this will probably be our baseline scenario. So that's how Leap actually knows where to put things. And then this variable ID in this case, I can't tell it right now, but there's a good chance that it is activity. And you can see that's higher number because it has room for a lot more. And branch ID in this case is also variable ID. Yeah, that's right. Is in this population. We also can see. So those things mean the same. It's just Leap's own database method for putting things there. That also means if you had this format, which is what is required, along with some of these area and model version and numbering, that is required for importing to Leap. if you have that, and then you think, okay, I want to change something in not key household size, but I want to change something like, let's say, the GDP, and you just delete your household size, and then you put your branch in for your GDP or transport or something else, where you always would have population, and then you write a new formula or new data, and then you think that's fine, let's import that, and then that will be changed, and then accidentally you have changed something in your population which could go wildly wrong. So you need to be aware of that, where these absolute ID tags is. I recommend building my branches, variables, scenarios, and regions and so on in Leap, exporting that in some way, and then importing, unhiding these branch IDs so you always can tell where the things are, and then changing and then importing back. So you change as little as possible inside of Excel, because otherwise it doesn't fit with the Leap expected format. If we look into the Leap model here in key assumptions, we can see that here we have household size. In our current account scenario, that is just listed as 5 people per household. And we'll go back to the Excel and we'll see how that's described. So here we can see here we have household size, and we have our scenario ID as 1. So that's current accounts. If you go further on, you can see it's just listed as 5 and only in 2010 our wage year. But let's then do something interesting. Let's say it is 200 now. How do we make this change into Leap? Well, going back to Leap, we can then say analysis, import from Excel, and we like to import as a data. That's usually the right way. And only replace constants, interrupt, step, and smooth expressions. That is for safety. If you're doing something more complicated, you have to turn off this, otherwise it won't import. And you can set match branches, variables, scenario, regions by names instead of IDs. That is usually not recommended to have on, because then these region IDs is no longer the valid ID number, but what you have written as the different names of the scenarios, regions, and variables are, which lend itself more to errors. So if you say OK, import data will replace any expression in your dataset. Want to continue? Yes, let's do that. Then scanning the open Excel sheet, you have to have that the last open Excel sheet is the one that it imports. And now you can see that it is, yeah, it edited some units that I ignored. That should be okay. That's just a minor thing. Now it's going through all of our scenarios and seeing where we have changes. This might take a little bit. Now, of course, if we don't want to have that take as long, we could have just deleted a number of rows in our sheets in Excel, and it wouldn't be looking for so many things to maybe replace. We should see when we're done in a while that the scenario, the only thing that has seen a change or seen that has been updated in blue text is the one where we have actually changed anything. But of course you can change things everywhere. But now, so if you're going through the entire models, it is going to take a little bit of time. And now we are finally about to finish. That took about 6 minutes. So you might think, why did that take 6 minutes if you just made one change? That seems like a long time. Well, yeah, if you look here in the household size in our current account scenario, well, here we have the change to 100, so that I was actually correct. That's very nice. But we can also see something else happened, and this is where we get a bit of a problem. Here, for instance, in our pulp and paper, we can see now, if you look at the formula, now this formula is just an interp with every single year described into it. So what happened here is actually not so much an error in the import, it was an error in the export. So this used to be a much lighter interpolation, or I actually think it looks like it was a stepwise function beforehand, with just a few steps and then a final level. When I exported that, I exported it in absolute numbers for all years, and then when I imported again, I imported that. It reformatted it to be all the years. And when I imported that, it changed. It detected that as a change. So even though it didn't actually change so much how the data looked, I changed the formula of how the data was. So instead of having a step function with just 2 steps, now I have every single year described the same way as was before. And that can actually lead to quite a lot of problems. If you're somewhere in, for instance, transport, and I have dependents, these are now probably gone, because all the places where that had an otherwise interp or step function, because remember we said only to replace step functions, otherwise these would have been hurt too. Now, or only replace interp, step, and growth functions. Now we again, this is just a linear line more or less, or it was supposed to be just 2 points, and now we have that as given us every single year. So the question is, how do we avoid that? So now we're going to look at how to avoid the import-export errors. So generally speaking, when we're doing with the exporting, what we want to do is we want to export only what we want to change. It is generally a bad idea to do all branches in terms of exporting. So now you can see I've chosen just the other industry, where I clicked in my leap model, and only the scenario and variable that I wanted. So in this case, it's just one. And now I have for every year, and I can change that. Another thing, we can actually delete the different both rows and columns in the leap. So here I have a big export, because maybe I want to do a big batch export, and I can just delete those. It doesn't hurt anything in the leap model, because I'm just deleted them in Excel. But what happens if I'm now deleting them, I cannot import them. So if I do a mass deletion of the rows, I can actually it won't get touched there. And the smart way of that, of course, also to do that is to use the little arrows that we have here to do a table filtering in Excel, like it's an Excel quote-unquote table. So we can put a filter on it and then delete everything we don't want in our filter. So a combination of that. I can also actually delete columns in Excel. I hadn't showed that. Not everywhere, because you need of course the branch variable and scenario IDs. You absolutely always need those. And other than that, Leap is looking at in which column you are importing from. But what you can do if you are wanting to change something every 10 years or put in new numbers 10 years after you delete your rows, so you only work with the branches and variable scenarios you need. You can also delete some of the rows, some of the columns, where you have the different years. Meaning you can say, okay, instead of having every single year, we only have 2010, 20, 30 and 40, for instance, in this model. And then the interp function that will get imported to Leap will only contain these 4 years and then an interp between them. And then you won't have a number for every year. And the other benefits for these is when you're more specific and deleted rows, columns, it's less data that you need to import and export. And that also means it doesn't take 6 minutes, it will take 30 seconds instead. So that's a really, really good way of working with this. So to reiterate in a very more visual, practical way, how do we import avoid the import-export errors? So just to talk about what we did before as well, we can see that we selected this. This is what we selected in the branch manager branch window in Leap. So that's where we have that. But we can then choose. We can just choose to have just the one branch, but you can also say this branch and below. That's very practical if you want to look at a specific subsector. Say you want to look at cement subsector in industry, you just choose that, and then say you want to export everything below that, and then you also get the different technologies and the different categorizations under cement, like cement production and clinker production and so on. Then in scenarios, in here you can see we only chose one scenario instead of choosing all. So that was the active scenario we were in before we opened the window. So that's also a method of doing that. That's also a very good safety measure to make sure that we don't ruin a bunch of scenarios, because then it's a lot of work to get that back. I have done that once a number of years ago where I didn't have a proper backup either, and that took days to rectify because the only backup I had was outdated as well. So generally don't do that, and remember to use version control before you do a mass import. Then here in variables, we have said we wanted all the variables because we are doing a number of changes. And then other than that, what I want to talk about is to export expressions. So if you generally just export expressions, you have to write Leap expressions in your chains for it to be valid. Otherwise, it will throw an error. And that's also a really good safety measure. So you have to write these expressions so you will not have a decided standard value if you've done something wrong. So if you export as years, you always have the standard values, which is what you had before, but on a specific yearly toll basis, which is not great if you're importing it again, and then you will have the errors that we saw or the mistakes that you saw in previous slides. But if you do that with expressions, instead you will have to make expressions, otherwise it will just continue to be what it was before and it won't get replaced. So if you don't do anything with the expressions, Leap will see that as no change, meaning nothing will happen. It won't even change the coloring, so to speak, so it will just be the same. So, and you could even see, you can choose different forms of expressions. So in this case, you can actually just, again, with the coloring that we had, some that are blue, some that are gray, and so on. So the scenario expressions are the ones that are blue in different scenarios. So in current accounts, it will be all of them. But if you have a baseline scenario that then inherits to a mitigation scenario, if you then export the mitigation scenario, you will only export the branches where that has expressions that are specific to that one scenario, which is very, very practical. You can also do the other thing is or the opposite thing, where you are exporting the inherited expressions, so you're only exporting those that are not inherent to that specific scenario. And that's good for looking at the control and where you actually want to, you want to change something away from the baseline, and then you can look at that instead. In this case, we're changing all the expressions. You can also change to how many levels. I usually just go full 8, but you can also say if you are in, let's say, the demand and you want to change something, but you only want to change the overall activities of your macro sectors in the different or the different subsectors in the macro sector. So you have something like transport and then different vehicles, and then you have industry and then the different industries, and that's, you only want to change the activity level for these. Then you can choose to only go 2 levels down, and then you won't get all the micro changes with technologies and everything on that. Then you just get a simpler output, and you won't touch the other things, other than of course that they are inherent on these macro changes. The practical thing is also with expressions that we're going to show in the next slide, is that you can copy paste expressions specifically, and those can of course be as complicated as possible, or as you want, to multiple branches, meaning that you can create some very, very big changes. So that's what we're going to do here. So here we are going to export some expressions instead of years, and we'll show some of the benefits of this. So here we have one that's exported with years. You can see the years are chosen as 2010, 2011, and so on. And here we have this exact same thing, but with expressions instead. So here we have the clear expression instead of just the year. So these are much more expressive, but of course they won't be charted in Excel or anything like that. So some of the benefits for that we will look in the next slide. Here I'm going to go through an example where we are doing a batch export, batch import, where we're doing a pretty big batch change in Excel, where we are going to add a calibration factor that we're going to use throughout the Excel for our industry. So let's look. So here we can see I have in my demand, I'm going to go choose industry, where we have all the different sub branches of that. So I am choosing now I want to make a calibration factor in Leap. So I'm going to make that now. So I'm going to make that in key assumptions. So I want to make a calibration factor that only covers industries, but all industries in this case. And that could be as specific or as broad as you would like. I just want to make the branch here so I can use that later on in Excel. So you can see here now I made one that I call industry cali factor. So that's my calibration factor. Right now it's 0. And it is, I made it 1 now because I want the standard to be 1. And then I want that to occur in all scenarios. So now if I multiply that with another branch, then it will just stay the same, but I have to add this link to my calibration factors to a multitude of different different sectors in my activity levels where I want my calibration to occur. Of course, I could put calibration on my energy intensity and everything else as well. But here, I'm now going into a random place where I want my calibration factor to have, and I'm going to add that manually. So you can see here now I have my key industry calibration factor. So that is how Leap knows it's supposed to look like, because this formula works. So I am going to save that because I'm going to need that for a number of other branches. And again, if I did this manually, I would have to do that every single time, or I would have to copy and paste. So copy this as I do now, and then paste that to every single place I would need to do it throughout the branches in my Leap model. But I'm a little lazy, so instead I am going to save that on the side, this formula or this add-on, and then I'm going to batch export industry and below for all the scenarios, because I want industry calibration in all my scenarios. And I only want it for activity levels in this case, which I chose before. So I only do it for activity level, and I do it for expressions. And I only do it for scenario expressions because then I won't get duplicates. So if something is inherited, then it won't show up now. So if I change something in Excel that inherits to another scenario, it will impact all the scenarios, but they won't be divided anymore, because they would do that if I had all expressions and changed all of them. So now I define specifically what I want. So you see, it's not that many right now. It's about 16 changes I would need to do. These could be in the hundreds too, depending on what I want. I have it for different scenarios. I also have it for different scales, and now I figure out that, well, I actually don't want it everywhere, because if we have a share, for instance, We don't want to put a calibration factor on that because that would ruin it, because we would get to a total shares above 100, which Leap will throw us an error, and that's not also where we want to do a calibration factor. So now I am going to here into my filter, and I'm only selecting the shares, and then I'm marking the lines that has the units as share, and then just deleting them. Then when I go back again, now I have no places that has shares. I do have shares, but saturation, that's fine. Our percentages with saturation, and that's completely fine. But now I'm happy with where I can do things. And that was very quick. I didn't have to look around too much to do that. Now I have my expressions, and you can see, oh, here, that's where I want my key industry factor. And that happens to be the exact same place as I did it before. And of course, I could do that manually going down through the different rows. But again, I think I'm going to be lazy. And I think, especially if it was hundreds, I don't want to do this manually. So instead, what I'm going to do, I'm going to go somewhere random where there's nothing in the format that we need. Then I'm going to copy all my expressions to somewhere also random, but where they have the same, in the same rows, but somewhere else in the columns where there is nothing beforehand. And now I can tell in my Excel, do something quite smart, and I can tell it to say that my expressions need to be one and the other, because now I still have the growth in the same line. Oh yeah, sorry, in the growth we don't need that either. So we're going to delete that line, which means what I copied also got deleted. So that's completely fine. That was an oversight on me both then and now. But now I'm going to say my new expression should be the old expression, and that could be anything, in this case just a number. And I'm going to make that relative so it can move around in Excel. And then here I'm going to put the double dollar signs in Excel, so it's a fixed value. So that means it will take the 600, and when I take that down, that will take it for the next rows, but it will always do the key industry cali factor. So now it changed all my values very, very easily. Now I'm just gonna mark that so I can delete these, because these are not in part of the format. So it might, depending on where I put it, I might actually hurt when I come back. So I'm just gonna copy them, the new values I want, and then insert them as fixed values. Then now they're no longer Excel formulas, so that means I can delete the other things I had before, which is not what I'm doing. And now my format is still the same. It's perfectly as it should be. I just remove the places where I don't want to have any changes, and I remove the temporary places where I use for making these changes. So now I can import. I say I'm gonna import. And here I don't remember if it's just interp, because I have a multiplication, so I took that off. But because I have so little places I am actually importing from, because it's so little, I'm okay with doing that, I think, in this case. I'm actually not sure if they would impact or not, but if you have something more complicated, like we did in transport, you have to take this off. So you can see that the iron and steel in the activity is like 600, 400, 1.8. We just want to make sure that's the same as it was before. We haven't imported. Still throws the same error because it's an old model, or it's a warning. It doesn't do much. And now suddenly we have changed this to be a key industry cali factor. And now the important part is, because it's just a link I put in there, if I change the industry cali factor in my key assumptions, they will be impacted all over, because now they're linking and being inherent to. So I made quite a big change in my industry for putting this calibration, but it would actually not, it has no impact right now. That was on purpose. But when I wanted to have an impact, I just need to change this value in key assumptions. So I then can quite dynamically change all 16 activity values that needed to be changed in this model. And again, in a real model, if you were to do something as broad as industries, there's a good chance it would be 20 to 50 values where you do that. And I did that in in less than 5 minutes, which is quite nice. And if it had been 200, as long as I knew exactly what I want to go for, I could do it at almost the same speed, which is quite powerful as a backend tool. You won't see it in results really, but when for your own sanity and working speed, this is very practical.